In this lesson, we'll be working on partial quotients using 3 and 4-digit dividends. In the first problem, we will be dividing 647 divided by 4. So we're going to rewrite it. Draw our big 7, or just the long line. Could be called either one. Okay, to begin, we want to think, are we going to use multiples of tens or multiples of hundreds or multiples of 1,000? So if you think mentally, just 4 times 10 is 40. And we're dividing 647, so that's quite large. And again, mentally, if you just think 4 times 100 would be 400, this would be a good starting point. We know 4 times 200 would be too much, so we're going to go ahead and start with 4 times 100, which is 400. Subtract what you've already divided out, and you have 247 remaining. Now, sometimes this step can be challenging for students, so obviously 100 would be too much. You only have 247 remaining. So I use these front two numbers almost just like the standard algorithm to kind of guide them in their multiples of 10. So here I could go ahead and use 4 times 60, which would be 240. And that's the closest I could get. Subtract, I have 7 remaining, so that's still greater than the divisor, so I still need to divide one more time. So I can do a 4 times 1, which is 4. 3 remain, which is less than what I'm dividing by. So my answer to this problem would be 161 with a remainder of 3. In this problem, we're going to divide 835 divided by 5. So first we're going to go ahead and rewrite it. Extend my line down. And students can go ahead and start thinking mentally. We know 5 times 10 is 50. Pretty much our highest multiple of 10 would be 5 times 90, which is 450. Pretty far away still from 835. So we can try our multiples of 100. So we're going to just start with the 5 times 100, which is 500. Subtract, and we have 335 left. So now we're going to think of multiples of 10. So 10 times 5, 60 times 5 would be 300. We have 35 to divide remaining, so now this is just a bit basic fact. 5 times 7 is 35 with 0 remaining. In this problem, we're going to divide 1,437 by 4. So in this problem, we're going to use our multiples of 100 to begin. So students can think mentally through this. I'm going to go ahead and show you my thinking to the side. So if we start with a 4 times 100, that would be 400. A 4 times 200, it's 800. And since we're dividing 1,437, I'm going to just go ahead and jump to a 4 times 400, which is 1,600. That's going to be too much. So we're going to go ahead and start with 4 times 300, which is 1,200. And we have 237 remaining. So we know if we did 4 times 100, that's too much. So we're going to think multiples of 10 here. So 4 times 50 would be 200. And again, not every student has to pick 50. That's the closest you can get. But if a student did a 20, they might just have to do an extra couple steps. So subtract. We have 37 remaining to divide, so we could do a 4 times 9, which is 36. 1 remains. So our answer is 359 with a remainder of 1. And again, in 4th grade, you can just leave the remainder as R1. We do not take it to the decimal point. So this is the same problem as the last one. I did want to show you that not every student has to follow the same exact steps. Ideally, when they get to 6th grade in the standard algorithm, they will have to, so we'd like them to get as close as possible. But this method is very forgivable and just allows you to add steps if you don't get the closest multiple as possible. So I'm just going to show you with just using easy numbers, multiples of 100. So just 4 times 100, so 400. And I still have 1037 to divide, so I can do another 100. And I have 637 remaining, so I can do another 100. And as you remember from the last problem, there we are with our 237. Now, I can go ahead and do multiples of 10 or 20, so say I start with the 20 first. 4 times 20 is 80. Under 57, so I'm going to do another 20. 77. And now I will have to do a 10. 37 remaining, just like the previous problem. And I can do a 9 with 1 remaining. So now I just have to put all my work back together. So yes, it took more steps, but again, if that's what your child's successful at doing, that is fine because it's using place value. So 100, 200, 300, 20, 40, 59, 359 with a remainder of 1. In this problem, we're dividing 2,456 by 4. So again, start with, obviously you're not going to use your multiples of 10 since this is quite a large number. If you think of multiples of 100, 4 times 100 is 400. Then even try thinking out loud, 4 times 1,000 would be 4,000. That would be too much, so we're going to go ahead and start with multiples of 100. And I'm going to start with 4 times 500, which is 2,000. Again, you do not have to start with that. There's many different ways to do this problem. So you have 456 remaining. So now I can go ahead and just do a 100. 4 times 100 is 400. I have 56 remaining, so a 4 times 10 is 40. 16 remain, and 16 divided by 4, or 4 times 4 is 16. So this divides perfectly. There is no remainder. So 614 is our quotient.